This is 2020 AMC 10A problem number 17. Define p of x equals x minus 1 squared times x minus 2 squared all the way up to times x minus 100 squared. How many integers n are there such that p of n is less than or equal to 0? A. 4,900, B. 4,950, C. 5,000, D. 5,050, E. 5,100. Okay, so we want this value here, we want this expression to be less than or equal to 0. So let's take the case that we want it to be negative, so less than 0. So what do we need for that to happen? Well, we have an even number of terms here, which means we need an odd number of positive terms, because then that would leave us with an odd number of negative terms, hence the whole expression would be negative. And also we can realize that we're subtracting by a larger value each time. So that means if you have a number of positive terms, so it's like positive, 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 and then you get a negative, you can never get a positive after that because you're subtracting by a larger value each time. So that means it's going to keep on staying negative. So yeah, let's try to get some positive terms. So let's say we only want the first one positive, because if we have the first one and the second one positive, the whole thing stays positive. So let's say we want the first one positive and the rest negative. So what could we do? So like, for example, we could have it be 2, we could have it be 3, and then once we have it be 4, it becomes 0. And well, 0 is actually okay because it wants to be less than or equal to 0. But if 0 is okay, that 4 is okay, that means 1 is okay as well, because that means the first term is 0. So there are 4 terms here, and we can realize that these 4 terms lie in between the interval 1 squared. So if we say that x can be any of these terms, so x can be any of these terms, x lies between the interval 1 squared and 2 squared, inclusive, because 1 squared is 1 and 2 squared is 4. That means, so obviously that we know that if we have two numbers, so if here we have 4 and 1, right? If we have two numbers 4 and 1, the number of numbers between them inclusive will just be 1 minus 4 or 4 minus 1, just the absolute value of whichever way you want to do it, and then plus 1. So we can express this more generally in terms of x. Say 2 squared is x, so this is x squared. Or I'll use a different variable. Let's say this is y squared, so I don't want to confuse you with other variables. Then this would obviously have to be y minus 1 squared. So x would have to be in between this. And this is not actually x anymore. Here, I'll make another variable for this as well. Let's say this is z. And z would be like this. Now, obviously, we would have to alternate intervals. So it couldn't be between it's between 2 and 1, which means it can't be between 3 and 2, because that would leave us with only two positive values in this, 2 positive terms in this expression, which would leave the whole expression positive in the end. So we have to alternate y's between like including one, so like between 1 and 2, but then not including 3, and then including it between, so including it right here, and then including it between 3 and 4. So we have to alternate it again and again. But for now, just let's say that we want an interval y. So we're generalizing this, what we have here. We're just trying to generalize that. All right, so how many terms are there between y squared and y minus 1 squared? Well, we would have to take an absolute value, but since we know that y is a positive integer, and we also do know it ranges from 1 to 100, because that's why we're trying to generalize here. So we are given that it's a positive integer, therefore we know that y squared is larger. So we don't actually have to add an absolute value, because we can just do y squared minus y minus 1 squared. So we have y squared minus y minus 1 squared, and then plus 1 because it's inclusive. And this will be the number of possible values for z. So let's say possible values of z. So we can simplify this. It's y squared times or minus y squared minus 2y plus 1 and then plus 1. So these cancel out. This minus goes to this one. So this one and this one cancel out. And we're left with 2y, since minus and minus make a positive. So we have 2y in any interval, which is 1 to 2, 3, oh wait, no, not 3. Oh yeah, 3 to 4, 5 to 6, and as you see, it keeps on alternating. But we need a way to make this cleaner because we can't just subtract every single interval that doesn't work and then count all of them and then subtract all of those, because that would be too time consuming and too tedious to actually do accurately, and you would probably mess up along the way somewhere. So instead, let's try to write this as a summation. So we have summation. And we want every other interval. And a great way of doing that is, well, we can realize that y, we always want y to be an even number. Because if you think about it, we're defining y here to be 2. In this example here, we're defining this to be y. If y was 2, we would get these possible values for x. So we want y to be the greater one. So if we have 1 to 2, we have 3 to 4, we have 5 to 6. We're alternating intervals, and these numbers are all y's, so to speak, and they're all even. Which means instead of alternating intervals, we can just use the summation to write even numbers. So let's say this is k equals 1 to 50. So instead of alternating, we can just write 2k. So we have 2k. And 2k gives us all of the even numbers from 1 to 100. And we have to multiply this by 2 since we got 2y here, because we're replacing y by 2k, where k is from 1 to 50. And we have to sum all of these. So simplifying, this equals k equals 1 to 50 of 4k. And we can take the 4 out. So it's k equals 1 to 50 of k. So we have to find the sum of the numbers from 1 to 50 and then multiply by 4. And the sum of the first n numbers is n. I'll just write it down here if you don't know about it. Sum of first n numbers is n times n plus 1 over 2. So this summation here will just be the sum of the first 50 numbers, 50 integers, or 50 natural numbers to be exact. So we have 50 times 51 over 2 times 4. So this becomes a 2, and this is 51 times 100, which equals 5,100. That gives us an answer choice of E.